Alrighty, let's try this with my voice a little louder. I guess my iPhone needs to be replaced, but let me know how this goes. All right, guys. So update. My storage cut short, so I had to stop where I was. But let's sit down and do what I did. We're gonna recreate um, the few quick lessons that I learned from Ed Leedskalnin by reading his book Magnetic Current. Now, there's a lot to absorb to reading all this, and there's so many mysteries on Ed's life and what he did and how he raised the stones, and then you add all his astronomical stuff, and then you add his electric and his magnets and his theories, and then hear how he shows you what he's saying and how he came to his conclusions. So let's go ahead and just do a brief little number one update course here. Um, Here's my notes, and the way I can really comprehend this is by the notes that I wrote. Not so much it was reading the book, but pulling notes out of that. Um, there's a lot here. So let's just start off by, I'm going to go ahead and this is not a magnet. Okay, it just falls off. And this is wound the opposite way. So I believe this is wound clockwise. This is wound counterclockwise. I believe so, yes. Hooked up 12-volt battery. What we're going to do is we're going to do what physics says shouldn't happen. Is we're going to create electromagnet here, but what we're going to do is disconnect the energy, and the electromagnet stays the way it does, and we'll talk about that. And that you'll see that coming up in Ed's writings, how we work on that. So I'm going to go ahead and attach. This is one hand. I'm going to go ahead and attach the positive side, so it's a dead short. Usually I don't like to leave it connected. I like to just disconnect it and give it a jolt. So that ain't going to happen now. So we're going to connect this. Okay, and we're going to connect that. So the power just fell off. So we got no power connected to this apparatus. And this is called Ed's PMH. And here we got this steel bar attached. Why do we have it attached? How is it attached? Well, Ed's going to explain to us in his magnetic current how it's attached. Strong. Let's go over here. Now, I kind of just made myself notes. And as a joke is, I went from the back of the book, and I'm using the pages in the opposite way you normally would. So I started off that this writing is lined up backwards as a joke. But I want to talk about some things here. We're going to start off with the basic that Ed talks about, and we're going to go through the system that Ed left us. Well, all he left us was that book, Magnetic Current. Okay, we have a couple versions. This I bought from Coral Castle. Okay, but it doesn't have any drawings inside. It just has a drawing on the front. Now, I also have this, came from Coral Castle as a pamphlet. And this pamphlet Ed put in a newspaper called Minerals, Vegetables, and Animal Life. And there's a picture of his perpetual motion holder. And that's what we're talking about here. Here's a picture that Ed left of himself with his machine. And you can see that there's things going on. There's crossbar we're going to talk about in some stuff here. He's got chains coming down off this wooden box. And he's got a tie down wire on that side, on this side. And these little things right here are valve. They're valves. He bore a hole in the wood and he put the valve in. Now in the middle of this wood underneath, there's a routed out area also. So we're going to down the road talk about that. Here's the box. Wire comes up, goes to whatever that is. When I was at Coral Castle, that pipe has a flange like that, but then it also has another ring that's welded and screwed and off to the side. So as you look deeper in this picture, you can see that this round thing is really two things. And then he has baling wire wrapped around the outside. So that would make both of them connected. And that would, to me, be two capacitors, like a Wimshurst machine where you ground both outsides out, and the insides above these capacitors become their own polarized side. So basically, one would be positive, one would be negative. Okay. So let's go ahead and start off here, and we're going to. This is going to be good for you guys. You guys are going to love this. So, I'm not going to read all my notes, but I'm going to look at the parts um, that are important. And we'll start off in the beginning, get through the first page. It says, in permanent magnets, they are circulating in metal in great numbers. So right now in the metal, they're circulating, but that's permanent. That would be these guys. These guys right here are permanent magnets. This is a this is a just something different. It's a electromagnetic field, PMH, and we'll get into what it is. I don't want to spill the beans right now. Impermanent magnets, they are circulated in the metal in great numbers, and they circulate in the following way. Each kind of magnet are coming out of their own end of the pole and are running around and running in the other end of the pole and back to its own self. So that means that here's the positive, here's the negative. They're coming out, coming around, circulating around and keep doing a circle. And the other ones from this side do the same thing. So you have obviously two avenues that are circulating. So they run around and they run around their own end. And then over and over again. All the individual magnets do not run around. Some run in and some run away and never come back. But new ones take their place. I drew the circle, and you can see the north south pole, and then this is the negative, and that's the positive, and this runs around. The positive comes out North Pole, runs out from the North Pole, runs in through the south and back up. So you could take our planet or sphere magnet, cut it in half this way, and that goes into Ed's astrological stuff of astronomy and of crescent moons. And we'll down the road get into that. And I just want to give a kudos out to my friend RL from talking to Ed Leedskalnin, and I'm going to give kudos out to my friend Scott Russell. He's made by one man. And I look at all three of us as Ed Leedskalnin guys in different types of interest. So RL Pool's interest, talking to Ed Leedskalnin, is more based on astrological parts of Ed, which he speaks a lot about, and how it ties together with certain attributes of what we hear about Ed. And then you have Made by One Man, Scott Russell, his website. He also works on the sculpting and the chipping way of how you can use this wheel to create the crescent moon and different parts of what Ed has made. And then also you have Vinny St. Vincent, myself, and what you have there is the wheel and the works of the wheel. So let's dig on. Now, the magnets can be sent out in straight streams. And whatever kind of magnet you are sending out, the other kind of magnet is coming back to you. So that is very important stuff, guys. That's saying my eyeballs are sending out to look at this not only a magnetic field but a pole, and that pole is responding back, and the opposite pole is coming back to my eyeballs. I want you guys to really focus on what I'm telling you guys in different ways. So different notes I made is lifting strengths of magnets. The North Pole uh, lifts more than the South Pole. Okay, so get that as your notes. Pushing strengths. The South Pole magnet pushes more than the North Pole magnet. But this is all if they were hanging. But if on ground level, they're equal in strengths. Okay, so guys, make that notes part of what you need to know. The other note is, what is magnetic current and magnetic having to do with magnetism, current passing from one to another. Sometime that flows as a stream. So we're going to think of water, okay, guys? Water. So now I'll tell you how magnetic current is. Magnetic current is the same as electrical current. Current is the wrong expression. Why is it the wrong expression? Because there's really not one current, there's two. One going against the other. Composed of north and individual magnets in concentrated streams, and other composed of south pole magnets in concentrated streams. They are the running one stream against the other in a whirling cork screw-like fashion. With this, with high speed, one current alone cannot run. Okay, guys, make the notes. To make the magnets with currents from batteries or dynamos with a single wire, a metal will have to be put on the wire in such a way so that the magnets which are coming out of the wire will be running in the metal, starting from the middle of the metal and running out to the end, and not from the end to the middle, as they appear to be doing. So basically, what I'm looking at here is Ed's picture. Here's the metal we're talking about. Even though in his experiment he's talking about it, but I believe that's a darker side and that's the lighter side. Negative side, positive side. He's in this box. He's got this bar sitting on top of something. It's responding every time a north or south pole approaches this. So if you want electric, you would pull it from these two parts of this bar. Look at the chains coming off. Two chains, and then there's a wire to the right. So if you look at one straight bar, that's a bolt. So one side of the bolt would have a positive, which goes up to the top end of the capacitor. The other side of the bar, like this, would be negative. And that negative comes around, runs back up, comes over. It's not on this round thing. It comes up over here, comes back down, and that's the chain swirled up with the hook. Is the positive side. This whole center bar, all this center here, and the motor block is sitting on ground. It's grounded. Let's move on over here, guys. I hope you can hear me good. Um, let's move on over here. So if back to Ed's PMH. So if you want to make this a south pole heading towards you in a coil, right here he says how to make a south pole in a coil end. This is pointing to you. You will have to run positive electricity in the coil in a clockwise direction. So right here we are clockwise direction, and we're sending the south into that side. Important stuff here. I can tell you that the positive electricity has nothing to do with making a south magnetic pole in the coil. Each pole, south or north, is made by their own magnets in the way they are running in the wire. So basically what he's saying is there is no north or south. There's only a positive and negative. And these little itty bitty magnets are going to pick and go in their direction to be separated. So to have a positive and negative running in a single wire, you're going to have a positioning angle of how this is going to be working, and we're going to talk about that. So in let me read this real quick. Motion, running one kind of magnet in the opposite direction is why you put a magnet metal across the copper wire and pole ends. All right, so here you go. So this will explain this bar across the top here and how he's making this to be a positive and negative, and also how you can turn that into electricity. In a car battery, the north magnets run out of the positive terminal. Both kinds of magnets are running, one kind of magnet against the other. They are running in the same right hand screw fashion.